For any two sets A and B having m elements, then prove that the Cartesian product of A and B and the Cartesian product of B and A have m squared elements in common. Okay, let us try to understand the problem first. So here we have two sets A and B, and it's mentioned here that both of these two sets have m elements in common. So that means the total number of elements in the intersection of the two sets, that means A intersection B, is given here that this equals to m. This is given to us. And with the help of this, we need to prove, that means if we take the Cartesian product of A and B and we have the Cartesian product of B and A, that means they are going to have m squared elements in common. So total number of elements in the Cartesian product of A and B intersection with the Cartesian product of B and A, we have to show that this equals m squared. Okay, so how shall we proceed? Now, in order to find out the total number of elements that's common to both the Cartesian product of A and B and A, we have to take the help of a formula that we have already used in the previous problem. So here we know for four sets, if we have four sets A, B, C and D, we have, if we take the Cartesian product of the set A and B and then take its intersection with the Cartesian product of the set C and D, this is going to be equals to the intersection of the set A with the set C, and then we take its Cartesian product with the intersection of the set B with the set D. Okay, so in other words, if we now what we'll do, using this formula, we are going to make a transformation here. So here, let C Cartesian product with D, let this be equals to B Cartesian product with the set A. In other words, what we're doing, we're going to replace C with B and we're going to replace D with the set A. Okay, so set this formula was now going to become, so we have the Cartesian product of A and B intersection with the Cartesian product of C and D, but we will replace C with B and D with A, so that's going to give us Cartesian product of B and A, and this is going to be equals to, we need A intersection C, but C is going to get replaced with B. We have A intersection B, and then we are going to take its Cartesian product with B intersection D. What is B intersection D? So in place of B, let's keep it B as well as it is, and then we're going to replace D with A. So we have B intersection A. That means, in other words, if we want to find out the total number of elements in the Cartesian product of A and B intersection B and A, the Cartesian product between B and A, this is the same as finding out the Cartesian product of the set A intersection B and the set the B intersection A. Now, why did we use this transformation? The reason why we use this transformation, because finding out the number of elements when we have this in this particular format, it becomes easier. That means number of elements in the Cartesian product of A and B, this is simply equals to the total number of elements in set A multiplied to the total number of elements in set B. So here we have two sets. One of the set is A intersection B and the other set is B intersection A. That means if we use this particular formula, then this can be also expressed as the total number of elements in the set A intersection B multiplied to the total number of elements in the set B intersection A. Now, what is the total number of elements in A intersection B? We have already mentioned here that that's equals to m. So we have m common elements between the set A and B, and this is also the total number of elements in B intersection A. That's also going to be equals to m, which means now we have m squared. We have been able to successfully show that the total number of elements that are common to the Cartesian product of A and B as well as B and A, that's equals to m squared, hence proved.